Let's build a business intelligent AI assistant that reads data directly from your Google Drive documents, powered by the MCP server and a vector database using RAG technology. This AI retrieves precise information from your knowledge base, analyzes it intelligently, and delivers accurate, real-time insights for your business. A seamless fusion of automation, data intelligence, and retrieval augmented generation, transforming the way you access and understand your data. First, let's move on to generating a RAG vector dataset in Pinecone. Add a webhook or trigger node. In this setup, we'll use Google Drive as the trigger. When a file is created in the monitored folder, make sure you've already set up your API secret and API key from the Google Cloud Console. Also, ensure that the Google Drive API is enabled to use this node. Select your Google Drive account credentials, set the mode to every minute, and under Trigger On, choose Changes involving a specific folder. Select the desired folder from the list. In this case, I chose the Super Build Fitness folder from my Google Drive. Then, select Watch for File Created. Click Fetch Test Event to check if it's working. As you can see, the file has been successfully retrieved. Next, add another Google Drive node, the Download File tool. Use the same Google credentials for authentication. Scroll down and look for the Input ID field, then drag the schema index and drop it into the file input field. Execute the step to test it. Now, you should be able to view the downloaded file from Google Drive. Next, add a Pinecone node to call the Pinecone API. Make sure you've already set up your Pinecone account and have access to your API credentials. Select the Pinecone index from the list. In this case, the Super Build index. Under Options, add your Pinecone namespace. Then add an embedding node and use the OpenAI embedding model. Make sure you've also set up your OpenAI API key or credentials. Use the small model to convert text into embeddings. Add a document loader and select Default Data Loader. For the data type, select Binary and leave everything else as default. Now, let's test the workflow by executing it. As you can see, the dataset was successfully inserted into Pinecone. This dataset is now ready for use in the MCP retrieval workflow. Now, let's create an MCP server workflow. First, add a trigger node, MCP server trigger. Change the path to whatever you desire. In this case, I used MCP Fitness. Next, add a Pinecone tool and select the same Pinecone credentials. Select the operation mode, Retrieve Documents as tool for AI agent. Add a description such as, use this tool to retrieve information from Pinecone or any description you prefer. Select the Pinecone index from the list, in this case, Super Build. Toggle Include Metadata on. Under Options, add Pinecone namespace and enter the namespace, Super Build. All set. Close the node window. Next, add an embedding node. Select OpenAI and use the Text Embedding 3 small model. All set. Name the workflow whatever you want and save it. Enable active for production. To use this MCP, copy the MCP URL by double-clicking the MCP trigger node. Copy the production URL. Close the workflow. Now, let's create another workflow to test the MCP with the RAG database integration from Pinecone. Start with the trigger node, Chat Trigger. Add an AI agent node. Select the source for the prompt, defined below. Type the prompt in the box, for example, "You are a helpful assistant." Retrieve information from the MCP tool regarding the user input. Trigger the chat node first so we can generate a test data schema. Drag the chat input index from the left into the prompt box to insert an expression variable that provides sample data into the prompt. Close the AI agent window, add a chat model node and select OpenAI using the same credentials. Next, add the MCP server tool node. Paste the MCP server URL that you copied from the MCP workflow into the endpoint field. Make sure server transport is set to HTTP streamable. Leave everything else as is. Now, open the Google Drive folder where your knowledge base was uploaded. Take a sample question to see if the AI can answer it based on the knowledge base. For example, "Are pets allowed?" Trigger the chat workflow and submit the sample question. You should see the AI agent return an accurate answer based on the knowledge base we fed into the vector database and accessed via MCP. Imagine what we could achieve by applying this workflow to other use cases. For example, an AI assistant that can answer business intelligence questions based on accurate real-time data, whether it's sales forecasts, campaign performance, customer engagement metrics, or operational analytics. As long as you feed the AI with the right data set, use the right tools, and design proper workflows, the possibilities are limitless. This combination creates a powerful ecosystem where automation, data intelligence, and conversational AI work together, giving you a system that not only understands your data, but also helps you make smarter, faster decisions. Please follow for more updates and tutorial like this.